standardization. That was the idea, right? That's what we said, right? To have standardization, because eventually I would want to know that, for example, if he's a salaried employee and Darlene is an hourly employee, at one point if I have these two objects, I want to have one same way to call each of them to give me their salary. So I want to say, for example, I want to have one standard way to interact with them. I want to give me salary, for example. And I want to say exactly the same string to her, give me salary, and I want her and him to understand my command exactly the same way and give me the output I want. Maybe he will have to do some math that is different from Darlene in order to provide me that answer, right? But at the end of the day, I don't care about that. To me, that's like a black box. I don't know how it's done inside. All I know that is that I have to give him the input, ask him the method, give me his salary, and I know that he has to return me a double with his salary. Same with Darlene. I know that I have to make the call, give me salary. I don't know how the heck she does the math inside to calculate what her salary is, but I know that she has to give me back a double with her salary. Is that clear? Yes? So we saw that last class. And here we define our abstract class employee. We define our attributes, our constructors, getters and setters. And we define these methods to be abstract, right? Correct? Now, this provides a little constraint now. The constraint is that if this class employee cannot be instantiated, that means that if somebody wants to create an employee, imagine I want to hire this guy, right? He's my new employee. And I don't know yet if he's going to be hourly or salary. I don't know how I'm going to pay him. Back in the day, when we didn't use abstract classes, I could create him just as an employee, right? Correct? Remember we had man and woman and we said human because we didn't know if Pat was a man or a woman, right? And we could do that because human was a complete class, right? But now, employee is an abstract class. So if he comes to me, and they haven't told me yet if he's going to be paid hourly or salary, I cannot go ahead and say employee E equal new employee because I cannot instantiate employee. So I have the limitation now that I cannot create an object out of the employee class. Do you understand what I'm saying? Now, whenever I want to create an object, I have to go by one of the children. I have to choose you. Are you going to be hourly or salary? But I cannot do anything else. I cannot use the parent to create an object. Is that clear? Yeah. So that's a constraint. Okay? So that's what we played that class, and we created, and we said that when hourly and salary said that they extended employee, they had to do whatever they had to do, but they were obligated to implement this method, right? Remember the word I'm saying, they were obligated to implement it. The magic word, implement it. Why? Because in the parent class employee, it is not implemented. It is declared, but it is not implemented. Do you understand the difference? Yeah. Yes? The parent class says, public double calculate salary, semicolon. Just a header. It's declaring what the method is going to look like, but it's not implementing it. There is no body for it. Got it? Now the children, when they extend the parent class, they are obligated to implement that method that the parent left incomplete. And by implementing means put a body to it, like here. Make sense? And they have to respect the same exact name that the parent decided for it, including the parameters. Here, this method, for example, is not meant to receive any parameters, right? Correct? Right. So the children cannot, if the children decides to do this, then he can do that. But now this light becomes red because look at what it says. You're still in debt. You haven't complied with implementing calculate salary the way I want it. Make sense? So you can have multiple calculate salaries. That is called overloading, right? Remember we had many like overloading constructors, right? You have multiple versions of calculate salary. But since you're extending from employee, the minimum I want you to do is to have one that looks like the one I defined in the parent. That was after. Got it? Professor, could I have this class to be abstract as well? Could the child class be an abstract class? Yes, you could. In some occasions that is necessary. Okay? And if the child is abstract, then he does not need to implement the method. Do you understand what I'm saying?
Yeah, because you can't instantiate it anyway.
Exactly. That's why you're not obligated. But if your child is not abstract, if he's extending from a class that is abstract, he's obligated to implement every single method that was declared as abstract in the parent. Is that clear?
We don't have to do anything, you have to put a header in,
Just
once you
do whatever you
declare
want to
a
do.
concrete class, then how to do it.
He will have to do everything. And he will have to implement everything from his parent and his grandparent.
Totally.
Got it? Yeah, it's like you have the debt from your dad and your grandpa and you have to pay it off. Something like that. Right?
Well, pass it to your kids.
Exactly. Pass it to your kids, yeah. Yeah, that's the concept. You understand what I'm saying, right?
Yep.
Yes? So pretty much, I'm defining a class here. In this case, employee. I declare this class as abstract, right? Correct? Then I have declared my classes hourly and salary, right? These classes are concrete classes. Why? Because they do not have any method that is abstract. This guy is concrete and this guy is concrete, right? So these two guys have to implement any method here that has been declared as abstract. So they have to declare M, and put whatever M requires for them. Maybe alpha, here maybe beta. Doesn't have to be the same. Okay? What I'm saying though is that if I had a class here, say I had a class X, and this class were declared as abstract as well, he doesn't have to implement them. He's not obligated to implement them because he's abstract. But he can declare even more abstract methods. He can declare, for example, abstract N. Got it? But the moment that I make a child here that is concrete, YC, now this guy is screwed because he has to implement M from here, and he has to implement N from his parent. Got it? Is that clear? Yes?
Yep.
All of you? Yes?
Right.
Yes.
Alright, so you said that abstract on top, those two are concrete on the bottom, but what's the middle one right there? Because
The X here?
yeah.
I'm saying the way we have here is without the one in the middle. Okay? But if we had a situation where we had a class that extends from here, that is abstract, just like this guy, then you don't have to implement M here, like you have to do it here. You don't have to. And if this class is abstract, this class will have one or more method that is abstract also, right? Say method N, right? Now, the problem is that if later you create a class, say Y, that extends from X, correct? And this class is concrete now. This class will have to implement this method that was empty from his parent, plus the method of M that was empty from his grandparent,
Okay, so it's the same thing, but
at a low level. Is that clear with everybody? Yes?
So we can call methods from the top one as well as the middle one.
Sorry?
The bottom one can call methods from X as well as from the top one, E.
Why?
That one can implement
Correct.
methods
Have
from
to
X.
implement this and can call methods from here and here as well.
What did you say the last thing?
This Y class can call methods from here and here.
Okay.
Just for inheritance, that's known.
Okay, thank you.
But at the same time, the link is obligated to implement whatever abstract methods from his parents and grandparents. He has to implement this guy, right? Because this was abstract in X,
Right.
and has to implement M that was left undone when X was created.
What about the hours? Doesn't it accept that as well too?
Sorry?
Doesn't the Y also accept the H and the S, the salary and the hours?
No, these are brothers. These are at the same level.
Oh, they're all the same level?
Yeah, there is no inheritance here. Look. There is no inheritance, man. The inheritance is between here, here, and here.
Right.
These two guys are not related to this guy. This coming from here, this coming from here. Do you understand what I'm saying, or am I confusing everybody?
Yeah, a little confused.
Let me draw it to speaker, okay? What I'm saying is we have one class E, right? This class is abstract. Putting an A there, okay? Why is it abstract? Because it has one method that is abstract. In this case, let's call it M. I know it's called calculate salary, but let's assume that it's called M. Okay? So far so good? Now, this class can have multiple children. Right? A class can have many children, right? But one class has only one parent, right? So here we have, say, our class hourly. Here we have our class, say, salary. Right? Now these classes have been created as concrete classes, right? Correct? Is they even concrete
Meaning it
classes?
can't take
Sorry?
anything in.
Sorry?
Concrete meaning it can't take anything in.
I couldn't hear you.
Concrete meaning it can't take anything in.
Concrete means that all the methods inside are going to be concrete. They don't have any abstract methods. Okay, that's what concrete means. Like the opposite of abstract, right? Now, since this class is concrete and is extending from employee, is a child of employee, he's going to be obligated to implement M and put a body to it. Do this and that and that and that and that and that, for example. Right? Correct? He's obligated to put a body to M into his declaration. Is that clear? Yes?
Yes.
That's what we did. We had calculate salary as abstract, and then in our hourly class we had to implement calculate salary. Remember? Here was return rate times number of hours. Remember? Now here the salary is also concrete. So he has to take M and also implement it. Maybe in a different way. Maybe like this. I don't know. Which was rate plus bonus. I'm putting different colors because they don't have to have the same implementation. They can implement it differently. But both have to implement it exactly the same way. M, receives nothing, receives nothing. Got it? Just like it was declared there. And if it returns double, then returns double, returns double. Got it? So far so good?
Yeah.
Yes? What I'm saying is, if I have yet another children here, the third children, and these children, we call it, say, X, class X. Okay? And we said that this children is abstract. Now look, it's different from these two children. This children is abstract. So how many brother classes do we have? We have 3 sibling classes, right? H, X, and S so far, right? All of them are children of E, right? But X is different from H and S because X is abstract. So since this guy is a child of this, but he's abstract, he's not obligated to do this. Like these two guys. He's not obligated to do that because he's abstract. So we don't have to do this here. Right? Now, at the same time, since this guy is going to be abstract, most likely he will have another abstract method, say N, say B, right? Because he's abstract, right? He will have some couple of abstract methods, right? Correct? So far so good? All I said now is that at one point, maybe you want to have a child that is coming from here, or a class Y. In this class I want to be concrete. Correct? Right?
Yep.
Now, this class now says, I am a concrete class, I'm coming from this abstract class. I have the same obligation like these concrete classes had when coming from an abstract, which was implementing M, right? This class Y is coming from this abstract class X, which had these two methods just declared. So Y has to take N and implement it. Has to take P and implement it. And since this guy is coming from here, and M was never implemented in any parent, he has to take M as well and implement it. Now you got it?
So it doesn't take the X, but it takes the E.
It takes everything from X and E. X is telling him N and P are not declared, so he's declaring them. He's implementing them.
Okay, but does X get E?
X is a child of E.
Right, so it gets A, M, right? See?
You mean Y?
No. Since E is a child, X is a child of E, so then X implements A, M, C, right?
Since X is a child of E,
Right.
theoretically, he would have to implement M.
Right, okay.
But he doesn't have to because he's abstract. That's what I'm saying. Only if the class is abstract, he's not obligated to do that. You understand what I'm saying?
Since he's abstract, he doesn't have to.
He doesn't have to.
But
S,
could he if he wanted to? But then you have to make it concrete then.
you have to make it concrete then.
Right.
Okay? So you can. Actually, you can. You can implement it if you want to. You can implement it if you want to. But by X being abstract, he has also the luxury of having abstract methods in himself.
Right, I understand that part. And then, so then Y has to get E.
Has to implement everything
Everything
from
you
his
need.
parent and grandparent.
Correct.
Yeah.
So his parent left incomplete N and P, right? So he has to implement N and P. His grandpa left incomplete M, and X never took charge of that. So he has to implement M. Got it? Yes, sir.
Going back to what you just mentioned, let's suppose that X implemented M. So when you finally do reach a concrete class Y, do you also have to implement M again, or no?
No,
because
if
those are-
X implemented M here,
Right.
I'm saying he doesn't have to, but if M,
If you did.
can you look in, Henry, if X were to implement M here,
Yeah.
then he doesn't have to do it anymore,
Even as an abstract class.
even if it's abstract, okay?
Instead of
He
the
will have to
light
implement
source,
everything that was left incomplete, that's all, it's his job, okay?
Oh, right.
You understand what I'm saying? in charge of implementing everything that was left incomplete, that's all. Is that clear, guys?
Yep.
All of you? Yes? Yes, sir.
Alright, so let's say E, the way I see it is E is the bartender, right? And H, X, and S are all three people that are at the bar.
Okay.
X is an alcoholic, so he's choosing not to drink, but there's a 1 drink minimum per person. And Y, since someone has to drink, Y is going to take the drink that X is going to drink because E can't force X.
Mira,
You're shaking your head, yes.
I'm confunding.
Question,
You confuse me more, bro.
can Y accept also S and H, or no?
In Y accept H in S?
Yeah.
There is no relation.
There's no relation? Okay.
There's no relation. There is no arrow connecting them. This is a child of X.
Right, I know. But I'm saying, when you implement that, then it accepts also S and H.
Test.
You mean accept like to use any key that H and S have?
Yeah, you do
No,
like a branch for
because
them.
if you were to do that, he's asking me could Y also use methods from H and S? That would require to have something like this.
Right.
That would require that a class can have more than one parent, and that is prohibited in Java. Okay? You understand what I'm saying? Okay? That does not exist in Java. That exists in C++, multiple inheritance. But in Java, a child has only one parent. Okay? I like the example of the bartender. Okay. I'm going to give you something extra. How many of you guys, without being totally honest, how many of you are not in my class officially?
What?
How many of you are not in my class officially? Some of you are not, I know are not in this class.
Choose
Come on.
to.
You're the only ones left. Okay. Huh?
They probably showed up. They probably didn't show up because we got quiz.
Yeah, probably. Have they done interfaces in your class already? Yeah? Okay, good. We're going to cover that now. Okay. So you've learned about abstract